Welcome back. This is the third video on drawing chairs. So we started with just basic cycloalkanes, and then we moved to our cyclohexane. And now this is our third video in this series, and I want to just work on drawing two different drawings for our cyclohexane. I want to draw a chair and chair flip, and I want to draw a skeletal with our configurational isomers. So I want to take some time to connect these drawings together. Remember, both of these drawings are good for two different pieces of information. When we're looking at our conformational isomers, we're going to think about energy and that most stable conformation. So our best and our worst conformation. And then when we're looking at these skeletal drawings with our bolts and dashes, now we're looking at our arrangement in space. This is our configurational isomers. So we really need to connect them. So what I'd like to do is kind of work my way through a process of all the three ways to draw our cyclohexanes and connect each one to each other. So I want to start with a simple 1,2-dimethyl cyclohexane. All right, so often in organic chemistry, you'll just get a name of something and you'll have to draw it. So we always start our drawing with that skeletal structure. Let's just get everything connected. Let's get it in the right place. Let's make sure we know what cyclohexane looks like. Let's put 2 methyls on it and let's put them in the right spot. So here's my cyclohexane. That's all 6 carbons in a ring. And then dimethyl is 2 methyls on number 1 and number 2. So I'm going to go ahead and number. All right, so this is a great place to start. Now let's add to this question. What if this were a homework or an exam question that is asking you which configurational isomer has the most stable conformational isomer? Let's connect them. So now we need to look at both drawings in order to answer this question. So for our dimethyl cyclohexane, we have 2 configurational isomers. Let's draw them both. We have a cis and a trans. All right, those are our configurational. And then from each configurational, we have 2 conformational. So we've got a chair and a chair flip that we need to compare. So what we need to do then is make sure we put those methyls in the right place. Once you have a bold and a dashed on your structure, that means that it is specific in space. So we can't just willy-nilly put it anywhere on our chair. It has to match. So how do you go between chair and bolds and dashes? That's what we're going to tackle in this video. Let's take the first set. Our perspective when we look at our chair with the bolds and dashes, this is a very quick and easy way to tell that these are cis. But then how do we take that and translate it to a chair? Well, I like to number. I'm going to follow the same numbering the entire video. It doesn't necessarily mean that that's the numbering for naming. I'm just going to number to help me draw. Okay, then I'm going to take that and draw a chair. Let's just start. Oh, that's an ugly looking chair, isn't it? Let's start with a nice looking chair. And then let's add each group. So I'm going to number on the chair. So now on number 1, we have a methyl group. And now for our chairs, what we're going to include is anything that gives us that steric strain. If we're looking at energy, we need to put in the 2 methyls that give us steric strain. We don't need to include all of the other hydrogens. We need to include number 1 and number 2 has stuff on it. So number 1 and number 2 has stuff on it. I feel like I need to make this bigger. How's that? All right, so our number 1 carbon and our number 2 carbon is where we're going to focus. We have a methyl on both of them. Now, there's 2 different ways to look at this. My perspective is that when I look at this drawing here, I am literally looking at the molecule face on, and I am looking at this group coming out first, this group coming out first. They are literally coming out at you. And so what does that mean on the chair? I'm going to picture my eyeball then, when I turn that model set to the side to picture a chair, I'm going to put each methyl group as they are the first bond coming at me. So if I'm looking at a chair, that means that methyl is going to be axial, because if my eyeball is on top, this is the first one I'm going to see. And then on number 2, okay, now it switches, right? Because axial is actually down here. That is not the first bond that you see. You actually see, and I'm going to erase that number 1, you actually see your equatorial, and you can draw it here or here. You just can't draw it straight up or straight to the side. So this is a major no. Don't draw that. That's the wrong angle. Remember, that's SP3. So I actually typically prefer to draw it to the inside so I don't goof up and draw it straight up. So now if you're looking at your chair, your eyeball hits this first and it hits this one first. That is what bold means. Notice they're not both axial. Bold and dashed do not correlate to just equal axial equatorial. They are a spatial thing. You can have 2 bolds and they can be axial and equatorial. It is all about your eyeball and which bond is first and which bond is second. So then if I wanted to include on this drawing, my hydrogens are the second bond I would see. That is the hydrogen going away from you. So then let's take that as the chair flip. Now we learned that in our last video. If we're about to flip that chair, let's put our 1 and our 2 in. So this is number 1 and number 2. So number 1 and number 2. So now what happened to that methyl? We learned in our last video that every time you chair flip, you actually change. Everything that was axial is now equatorial. Everything that was equatorial is now axial. So watch this. Now that methyl is equatorial. And what about on the other side? Okay, well now that methyl, oh, I better color code the same. I'll keep my methyls pink. Okay, so now this methyl is equatorial. And then what about on number 2? That methyl is now axial and your hydrogen equatorial. Okay. Awesome. Okay, no, just really quick, between the 2 of these with steric strain, is one better than the other? They are actually the same. Why are they the same? We have one axial and one equatorial. They are exactly the same in energy. Okay, now hold your seats, shut the front door. Let's take this one and go back to bolds and dashes, and let's see if we still have cis or trans. What does the chair flip do to your configuration? I'm going to put my eyeball up here, and now let's go backwards. On number 1, the first bond you see, is it the pink one or the green one? It's the pink one. That's the one on top. So that is going to be bold. And now on number 2, what is the first bond coming right out at you? It is the pink one again. What? Look at that. And then look, your hydrogens are this second. They are behind the pink bond. So look, actual chair flip does not change your configuration. Remember, it should stay the same. It's just a bond rotation. So we've got to get good at going back and forth between bolds and dashes and the chair because they tell us two different things. Our bolds and dashes give us very clearly that these are on the same side and these are cis. And our chair gives us very clearly, these are the same energy. All right, well, we had a challenge in this problem. We're not done yet. We needed to compare that actually to the trans and see which one is better in energy. So far, these are the same between these two of these. Let's see what our trans looks like. So this is nice and clear that it's trans. So how are we going to change our chair then? Let's draw this nice and big. Okay, on number 1 and number 2, that's where we have methyl groups. Again, your eyeball is up here, and you are looking down on that chair. Number 1 is bold, so that is that axial, not equatorial. All right, now on number 2, shut the front door. This is now dashed. So what does that mean? That means that it is not the first bond that your eye sees or the one coming out at you. That is your hydrogen. I'm going to draw this a little bit cramped there. Let's draw this chair bigger. This is like the Godzilla of ugly chairs. Oh my gosh. Okay, that first one is up here and down here. Okay, now the second one, is going to be out here is our hydrogen. So that needs to be green, doesn't it? Our methyl is the dashed. So it's the second one that we see. All right, so this is because this is dashed. This would be bold. So if we were going to include that, we would have that be bold. All right, so we've got this time in our trans, we've got axial. This is the worst possible energy. We've got both methyls, axial. Let's compare that then to the chair flip. Everything that was axial is now equatorial. So on number 1, that methyl is equatorial. On number 2, equatorial. And our hydrogens are now both axial. Whoa, now you've got both methyl groups equatorial. Shut the front door. This is now our best energy conformation. So if our initial question is to actually look at all of these energy conformations out of this whole thing, out of all 4, this is a sparkle pen, this one is your best energy conformation. And it turns out that this one is our trans. Now let's double check that. Let's put our eyeball up here. On number 1, that pink bond is the first one you would see. And on number 2, that pink bond is not out in the front. It's the second bond you would see. So that is dashed. All right, so we need to really just practice the chairs. Once you get the hang of it, there's nothing I can do except put a bunch of crap on it. So let me just start making up a few things. Let's just put a bunch of stuff on a cyclohexane and let's see if we can draw it. Let's take this one. Let's see if we can take that and convert it to a chair. And then we'll do a chair flip. And then we'll go back and make sure they look the same. All right, I'm going to number again. So on number 1, remember we only need to include what we have for sterics. So on number 1, we have that isopropyl group, and it is the first thing our eyeball sees. It is the first bond to come out at you right there. That second bond is the hydrogen. So that's our bold. Okay, then we go all the way to number 4. Oh, the plot thickens. Now that group is dashed. So that is actually away from your eyeball. You would see the hydrogen first, and that's the bold. Okay, now on number 5 is right here. Number 5 is bold. So that would be axial because that's the first bond that your eyeball sees, and then equatorial would be that hydrogen. All right, I love it. Now let's take that and let's do the chair flip. Everything that was axial is now about to be equatorial. So now your isopropyl is here. We go all the way up here. Now your methyl group is here. And then what about that methyl on number 5? That is now equatorial. Oh my gosh, I love it. Let's compare the two energies. Which one's the best and which one's the worst? Best, worst. Why? We have the most and the biggest groups equatorial. Let's go right back and add bolds and dashes. Okay, imagine, again, your eyeball is right here. So on the isopropyl, that is the first thing your eyeball sees. That is going to be bold. Okay, on those two methyls, well, this methyl, that is not the first thing we see. On this methyl, it is the first thing we see. There you go. We go right back to that cis here and trans here configuration. I love it. Let's do another one. Let's draw this one. What fun. We'll put 3 ethyl groups on there, and they are all cis. All right, let's take and draw our chair. I'm just going to go right ahead. Man, that's ugly. It's so different to draw with an eye pen. It's not, I'm not complaining, it's just different. And then we'll go right back up to here. All right, let's do it. All right, we've got 1, 2, 3, 4, 5, 6. We've got dashed on number 2. So if my eyeball is up here and number 2 is right here, then dashed means that it is actually axial. And our equatorial is our hydrogen. All right, number 4, dashed is away from you. Equatorial is that hydrogen. And then on number 6, dashed is also axial, and hydrogen is right there. Okay, holy crap, that already looks terrible. Doesn't that look like our worst energy conformation? We have all 3 of those groups axial. So then what's your gut tell you as soon as we chair flip? Aren't they all about to be equatorial? So we've got on number 2 a nice equatorial. Now our hydrogens are axial. Number 4, equatorial. Number 6, equatorial. And now if we go right back to our drawing, look, your eyeball is going to see hydrogen first for all 3 of those. So all 3 of these are the dashed bond. I love it. All right, let's do one more and then we'll stop and let you try this in some of the homework. This time we're going to take our chair and you're going to go towards the line bond structure and we're going to put in our bolds and dashes. So you want to be so good at this that you can go backwards and forwards. So let's take this and let's figure out what it looks like with bolds and dashes. So follow your process. Take your numbering. Okay, and let's number here. I love it. All right, on number 1, is that going to be bold or dashed? Dashed. On number 3, is that going to be bold or dashed? Remember, your eyeball is up here. Dashed. And then how about on number 6? Dashed. I love it. All right, so now we're going to stop and let you practice this in homework. Drawing chairs is going to pop up in several places this summer. It's definitely an essential skill, and you want to be able to go back and forth between both of these drawings because they tell us 2 different pieces of information.